Welcome to the video series on Research Methods and Analysis by Data and Research. In this video, we will learn about One Way Anova, how to do it using jamovi and how to interpret the result. We can do One Way Anova if the independent variable is in the nominal or ordinal level of measurement or are categorical in nature with three or more categories. For instance, imagine we are doing research in a sample from three different tribes. We plan to find out if the three tribes are different in their positive effect. Before doing the analysis, we have to make sure that the data is normally distributed and the three groups are homogeneous or equal in their variance while considering the distribution of the positive effect scores. Consider these as the curves of distribution of the scores of the three groups. These are the mean and variance of the distribution in each of the three groups. While doing ANOVA, the first thing we are concerned with is the variance in the distribution of the positive effect between the groups. The second important thing we consider is the variance of the distribution of the positive effect within the group. ANOVA's coefficient is represented by F, which is equal to between group variance upon within group variance. ANOVA is a distribution dependent test or parametric test with these assumptions. Using one-way ANOVA, let us see if the null hypothesis Tribe 1, Tribe 2 and Tribe 3 do not differ in positive effect. We will do the analysis using free open source software jamovi. To do ANOVA in jamovi, we have to choose the option ANOVA and from the drop down one-way ANOVA. We have four variables here: tribes, age, gender and positive effect. Among these, we are concerned with two variables, tribes and positive effect. Shift tribes to the box indicated as grouping variables. Shift positive effect to the box displayed as dependent variables. We can see the output of one-way ANOVA on the right. We assume that there is a homogeneity of variance between the groups. So we are choosing Fisher's F here. Here there is an option to check the homogeneity. Here there is an option to check normality. Here there are post hoc options. Assuming that there is homogeneity or equality of variance, I choose the post hoc analysis 2 key. All the results appear on the right side output view. First, let us know if our data meets assumptions, homogeneity of variance or equality of variance. I am copying the table on homogeneity of variance. This is the output table on the homogeneity of variance after removing the degrees of freedom from it. Homogeneity is equality of variance that is assessed using Levin's F. Levin's F score is 1.41 and P is 0.249, which is greater than 0.05. That means there is no significant difference between the groups in their variation of the distribution from mean. Hence, there is a homogeneity of variance or equality of variance. Going back to jamovi output, we confirmed using Fisher's F as our data met the assumption of the equality of variance or homogeneity of variance. Now I am copying the table on group descriptives from the output and pasting it in the Excel sheet. Copying the one-way ANOVA table from the output view, pasting it in the Excel sheet, removing the columns which do not have any information, increasing the font size, adding some necessary information to the table, removing standard error because I don't want to show it in the table, adding the information about F and its P, making some necessary changes, copying it. This is the ANOVA table. Our null hypothesis is type 1, type 2 and type 3 do not differ in positive effect. We will accept the null hypothesis if P is greater than 0.05 and reject the null hypothesis if P is lesser than 0.05. This is F, the coefficient that shows the difference between type 1, type 2 and type 3 in positive effect. And this is P or probability, which shows if F is significant or not. P is lesser than 0.05. So we will have to reject the null hypothesis. Referring to the mean and standard deviation, type 2 is the highest in positive effect. Type 1 is higher than type 3 in positive effect. Altogether, there is a significant difference between the three groups in positive effect. Here is the jamovi output for two-key post hoc analysis. I am copying it. This is a table on post hoc analysis. While comparing type 1 and type 2, the mean difference of the positive effect between participants from type 1 and type 2 is 1.33 with a t-value 0.77. Probability is 0.722, which is greater than 0.05. We have to accept the null hypothesis here because there is no significant difference between type 1 and type 2 in positive effect. Now, while comparing type 1 and type 3, the mean difference is 5.2 with a t-value 3. P or probability is lesser than 0.05. We have to reject the null hypothesis here because there is a significant difference between type 1 and type 3. Comparing type 2 and type 3, the mean difference is 6.53 with a t-value of 3.77. P or probability is lesser than 0.05. We have to reject the null hypothesis because there is a significant difference between type 2 and type 3. Hope you enjoyed doing One Way Anova. If you have any questions, suggestions or recommendations, please write to dnr365@gmail.com.